Hey guys, welcome to the video lesson for this inquiry lab, which is on the structure of expressions. So I'll give you a forewarning. This inquiry lab has a lot of things that may be confusing at first, but you don't have to know anything from this on a test. It's just to give you some background knowledge for when we move into expressions from chapter 6. So don't get stressed out over it. So in the first investigation, we're going to start talking about a couple different vocabulary terms. So the question says, Fitness Fortress recycles plastic water bottles. On Saturday, 8 bottles were placed into bins. On Sunday, 8 more bottles were recycled. So it says you can use an expression to represent the number of bottles that were recycled. An expression consists of a combination of numbers and operations. Each term of an expression is separated by a plus or a minus sign. So this is going to be really important for what we do today, is the word term. So let's start with step 1. Use a bar diagram to represent the number of bottles recycled Saturday, and use a second one to represent the number of bottles recycled Sunday. So Saturday, 8 bottles, Sunday, 8 bottles. No big deal. In step 2, it says the addition expression 8 plus 8 represents the total. How many terms are in the expression? So I want to go back to the definition of term right here. So each term of an expression is separated by a plus or a minus sign. So you see the plus sign? That means there's a term here, that this 8 is a term and this 8 is a term. So there are 2 terms in this expression. And it says, does the expression represent a sum, product, or quotient? Well, since it's addition, it represents a sum. Now, in step 3, it says, the multiplication expression 2 times 8 also represents the total. And here I hope you know that 8 plus 8 is the same as 2 times 8. So this says how many terms are in the expression. Now a lot of people want to say 2 because they say the 2 and the 8 are 2 different terms. But look back at the definition. It says each term is separated by a plus or minus sign. This is a multiplication sign. It's not plus or minus. So interesting enough, this is one term. Now, does the expression represent a sum, product, or quotient? Since it's multiplication, it represents a product. Now, below we're going to practice some of these words, and I'm going to do one with you, and then I want you to try 2 on your own because it's similar to 1. So notice the directions. The directions say work with a partner, that's me. Rewrite each sum as a product. So we're going to rewrite the sum as a product. Then identify the number of terms in each expression. So first off, let's rewrite 14 plus 14 as a product. Since there's 2 14s, you could rewrite 14 plus 14 as 2 times 14. Now, let's talk about the sum. So the sum is this one here, the 14 plus 14. The question is, how many terms are in it? Remember, terms are separated by a plus or minus sign. So this would be 2 terms because they're separated by a plus sign. So in the sum, there are 2 terms. Now in the product, since this is not a plus or minus sign, the whole thing is a term. So in the product, there is only 1 term. Alright, so just so you know, this line is where you rewrite it as a product. This one is where you tell me how many terms are in the sum. This one is where you tell me how many terms are in the product. Now I want you to do problem 2, which is a lot like 1, so use it as a model. Pause the video, do 2, and restart it when you're done. Go. Okay, let's see how you did. So first, the sum 92 plus 92 plus 92 can be rewritten as 3 times 92 because it's 3 groups of 92. Now in the sum, which is here, there are 3 terms because there are 3 numbers separated by plus signs. 1, 2, 3. Now in the product, there is still only 1 term. And the reason there's 1 term is because it's not separated by a plus or minus sign. So this whole thing, 3 times 92, counts as a term. Alright, so I know it's a little confusing, but the only thing you need to know at this point is kind of what a term is. It's separated by, terms are separated by plus or minus signs. Now we're going to go on to the next page. We're going to do this investigation to learn a little bit about something called the product of a sum. And then we'll do a couple problems together. So in this one it says, some expressions can be written as the product of a sum. So I'm going to highlight that because that's important. For example, 2 times the sum of 3 plus 4 represents the product of 2 and the sum of 3 plus 4. So the expression 2 times 3 plus 4 can also be thought of as the product of two factors. Totally kind of hurts your head to think about what they just said, right? Let me try explaining it a little bit better here. So this whole thing, this whole problem is called the product of a sum. And here is why. The product is because it has a multiplication sign here, right? And you know the product involves multiplication. Now it's a product of two things. It's a product of the 2 and it's a product of the 3 plus 4. Now, since one of these things is actually a sum. See how the 3 plus 4 is a sum? It's called the product of a sum. All right. Don't know if that makes sense, but just know a problem that looks like that is called the product of a sum. Now we're going to go through the investigation here. I'll show you how this one works. Now, in the investigation it says Melina and Kendrick are selling tins of cashews for a school fundraiser. Melina sold 5 tins on Monday and 5 tins on Tuesday. Kendrick sold 4 tins on Monday and 4 tins on Tuesday. So, I'm going to highlight something here so you can see. I'm going to highlight what was on Monday. So Melina sold 5 tins on Monday and Kendrick sold 4 tins on Monday. Now in red, I'm going to highlight what was sold on Tuesday. Melina sold 5 tins on Tuesday and Kendrick sold 4 tins on Tuesday. Notice on Monday, 5 and 4 is the same as Tuesday, 5 and 4. So in step 1, I'm going to divide and label each bar diagram to represent the amount sold each day. So Monday, remember, is in blue. So on Monday, there were 5 and 4 sold. And Tuesday, which is in red, there were also 5 and 4 sold. So I just split the bar, so there's 5 and 4 on each side. Now step 2 says write an expression involving a sum of 4 terms to represent the total amount sold. So in step 2, we could write this as 5 plus 4 plus 5 plus 4. Okay, let's write that down. Okay, now in step 3 is where we're going to change that to the product of a sum. Okay, so it says complete the expression below involving the product of a sum to represent the total amount sold. So here's what I want you to notice. Notice it's 2 times something, right? The 2 times means there are 2 groups of something. So let's look up at step 1 and step 2. There are 2 groups of 5 and 4. See how there's one group and there's 2 groups. And if we look in step 2, you see our 2 groups of 5 plus 4. So, to write that as a product of a sum, we say, we're right here now on step 3, there are 2 times 5 plus 4, because there are 2 groups of 5 plus 4. Now, in the expression above, in this one here, what are the 2 factors? Remember, factors are things you multiply. So the 1 factor is the 2. Okay? The other factor is the other thing we multiply, is this 5 plus 4 in parentheses. So, that's the other factor. Now, in this question it says, in the expression above, which factor can be thought of as both a single term and a sum of 2 terms? So take a look at this one. This one can be thought of as a single term because the parentheses. The parentheses group it together as a single term. But it's also the sum of 2 terms. Sum means add, and here are my 2 terms, the 5 and the 4. So when it says which factor can be thought of as both a single term and the sum of 2 terms, the answer would be the 5 plus 4 in parentheses. All right, bet your head's spinning right about now. It's okay, because we're going to do 3 and 5, and then you're going to try 4 and 6. You ready? So the directions say, rewrite each sum as the product of a sum, then identify the factors. So basically, if I highlight above, we're going from something that looks like this to something that looks like this. So let me show you how it works in number 3. So first off, we're going to rewrite number 3. Notice there's two groups of 1 plus 4. You see them right there? So we rewrite it as 2 times 1 plus 4. Remember, that means two groups of 1 plus 4. And the factors are the 2 and the 1 plus 4. Okay? In 5, here are my two groups. See them? There are two groups, so 2 times 79 plus 8 in parentheses. And the factors are 2 and 79 plus 8. All right, you ready to try 2? Remember, use those two as an example, or as a model. Pause the video, try 4 and 6, and restart it. Go. All right, let's see how you did. So, notice in this one, there are going to be two groups. But this time, it's two groups of 32 plus 2. They just had them in a weird order. So 2 times 32 plus 2. And my factors are 2 and 32 plus 2. And in 6, we had two groups here of 19 and 56. So we have two groups of 19 plus 56. And my factors are 2 and 19 plus 56. All right, if you had any mistakes, make sure you pause it and fix them before you move on. All right, last page here. I'm going to go through the odd problems with you, so 7, 9, 11, 13, and then you're going to go through the evens on your own. So let me show you how 5 works. In 5, the directions say, represent each expression using bar diagrams. So watch what I do. 5 plus 5, I do 5, 5. Okay, so get that done. Remember, pause anytime you need time to write. In number 9, it says, represent each expression using bar diagrams, then identify the factors. Now in 9, it says 2 times 3 plus 1. Remember, that means two groups of 3 plus 1. So watch what I do. I'm going to do 3 plus 1. There's one group, and here's another one, 3 plus 1. Do you see my two groups? Here's group 1, here's group 2. So my factors are 2 and 3 plus 1 in parentheses. And which factor is also a sum? The 3 plus 1 in parentheses is also a sum. Okay, pause if you need more time. Now for 11. 11 is the reverse of number 7. In 7, they gave us this, and we wrote the bar diagram. In 11, they give us the bar diagram right here, and we have to write 17 plus 17. Now in 13 is the opposite of 9. In 9, they gave us the product of a sum, and we had to draw the bar diagram. So in 13, they give us the bar diagram, and we have to write the product. So you see how there's a 5 plus 8, and there's another 5 plus 8. So that means there are two groups of 5 plus 8 in parentheses. My factors are the 2 and the 5 plus 8. Which factor is also a sum? Well, the 5 plus 8 is also a sum. All right, so now, pause if you need more time, but your job is to pause the video and go and do 8, 10, 12, and 14, the even problems. Use the one above it as a model. Restart the video when you're done. Go. All right, let's see how you did. So for 8, did you write 9 plus 9? Okay, for 10, we have our product of a sum, 2 times 5 plus 2, which means there's two groups of 5 plus 2. And the factors are 2 and 5 plus 2. Which factor is also a sum? 5 plus 2 is also a sum. Okay, in 12, we have this bar diagram, and you had to rewrite it as a sum, which is 74 plus 74. And finally, for 14, we had this bar diagram. Notice we have two groups. Here's group 1 and here's group 2 of 54 plus 58. So our product is 2 times 54 plus 58. And the factors are 2 and 54 plus 58. Which factor is also a sum? The 54 plus 58. All right, so told you your head's going to be spinning, but hopefully now when we go into the lessons in the next couple days, you'll have a little bit of background knowledge on what terms are, what products of sums are, etc. If you have any questions, ask me. As always, thanks for watching.